Hello. Today we'll take up in this video we'll take up the rail freight management technology. What are the information needed so that we'll be able to monitor and properly manage our rail freight system. We do know that in terms of the basic principles of ICT in rail freight operations, we are so particular about the position of the trains. This is very important, the position of the trains. So we can take note of that. Positions of the trains. And the next one would be which assets are on the trains. Which assets are on the trains? Like, for example, the locomotives. What type of locomotives, what type of rolling stock are connected to the trains? So this now calls for what? This calls for location number, and this one calls for say asset number, almost equivalent to your plate number of the car or serial number of the motor, for those of you who are familiar with engines. And then what the trains are carrying. What the trains are carrying, these are the cargo. So here you can have a SKU or you can have cargo number. And let's see. We have here the condition and maintenance requirements of the locomotives of the train. Conditions and maintenance requirements. So in effect, we need to know the maintenance status of the train. So sometimes we have a maintenance work order number. So these are four very important numbers that have something to do with the way we manage our train. This is an example of very long trains that are used for cargo. Delivered a batch of cars from Secha of the Slovenian port of Koper. Alright, so it is just interesting to see type of this type of train when it goes from country to country, which are landlocked, goes through a boundary like this. And you know, this is the long haul train. Is another long haul train, another long haul train hit there. You see, once it goes through here, it passes through what we call as a marshalling yard. What is a yard? A yard is a place where there is no shelter. It's open, but a guarded area where you can do things like store your items or perform work inside. That's a yard. And here on this part here, there is now a connection from the feeder train and the long haul train. The feeder train now will feed some of its content to this long haul train, and then some of this, once it's here, some of this will go to the other side and some will go here. Once it's here, now it's another point where it can be assembled, disassembled. That's how they do things, so that two networks can connect and interact with one another. And this is how they do on an international railway system. Furthermore, we would like to identify two types of recording system. Two types. One is to do what we refer to as the master files, and the other one would be the transaction file. In terms of the work that we do here, if you notice, TAPS is the operating system for the management of train operations. TRUST specifically record train running information and delay reason. the trust performs the transaction file, and so therefore you can see the delay here. And how about this? TOPS generates or record overall information about the train operating system data. So things like real-time information about location, loading, consignee, all of those. These are basically master file. Location, loading, consignee, location, loading, consignee, etc. are in the TOPS. Whereas in the master file, these are the delay, time of running, and so on and so forth. Together, you will be able to identify the errors in the system. Then we have the trust performs an important role in comparing actual train running times to those timetabled, allowing delays between locations in route need to be identified. And the information recorded by TOPS and trust can be used to improve rail freight service quality, for example, by providing evidence to allow the identification and subsequent elimination of recurring causes of delay or impractical timetable running times. So in the end, we would like both of this. We would like to use both so that we can eliminate. What do we want to eliminate? We want to eliminate unreasonable running times. And what else do we want to eliminate? We would like to eliminate delays. You know, these unreasonable running times, these are the schedule that are so tightly connected. For example, times that are so tightly connected that you cannot almost move. There's no chance for you to breathe from one run to another. Okay, so let's continue. This is another issue that we would like to ask our customer, or at one survey says, what do rail freight customer wants? See, in terms of what they wanted responsiveness to customer needs, and track and trace is only second. You see this? Most people want information about how things are, and they also want track and trace. They would like to know at what point in time a particular item is, where is it now? Despite the limited direct importance of the ICT service quality attributes to customers, the factors that are ranked more highly can be influenced by ICT applications. This is what we know. The cost per price of using rail freight was by far the most significant barrier, with the lack of a flexible service recovery strategy also being cited by more than half of the respondents. So cost per price is really, or cost or price of using an item is really the main reason why people use or don't use rail. Let's continue. Another issue regarding rail is the tracking and tracing of information for customers. Track and trace can provide reassurance to customers that their consignments are progressing as planned. This is what we refer to as visibility. And when this is not the case, it allows them to make alternative arrangement and implement contingency plans. Initiatives from rail freight service providers are given by Pacific National Rail in Australia and Kiwi Rail in New Zealand. So from now on, we'll be taking up some apps that do precisely this: generate information about rail and about cargo. One would be from a Pacific National Rail in Australia and Kiwi Rail in New Zealand. It's called CSX. One of the Class 1 railroads in the United States and operating in 23 states has developed a suite of ICT application under the name Ship CSX. Customers are able to look up prices and schedules, check wagon specifications, order wagons and truck wagons and consignments. So this is one important applications. It's called CSX. Let me just write that down. So we are now trying to write the apps. CSX, huh? And let's continue. So here there is a like a case study by D.B. Schinker. D.B. Schinker has introduced the Anobis order management system to improve customer service and enhance traceability in its UK intermodal business. Anobis provides the following range of services: EDI, order placement, electronic data interchange order placement, tracking and tracing, EDI interface with shippers, hauliers, ports and terminals, inland terminal and warehouse management, electronic paper trail and electronic invoicing. These are a lot of applications when you consider the number of users. Through an online portal, customers and other supply chain partners can track and trace containers and access the associated ordering and invoicing processes. Anobis handles all rail, road, and associated terminal services. So, this one particular case story about tracing container and container. Based on this is another example of a rail extract of planned schedule and real-time running for freight train source. So you have here the location, as I said earlier, location number, or having a very unique location name. Then arrival and departure, and real-time arrival and departure. And then its route. So all of these are scheduled. Other ICT applications that help rail freight to play its strengths. Number one would be, this section aims to demonstrate some examples of these wide-ranging applications in relation to heavy haulage benefits. And then we have performance and service quality. And then we have environmental safety benefits. So we will stop here for a while and we'll continue from here.